Hello, my name is Ido Gabi and I would like to present you the method I'm submitting for this challenge called mapping conceptual hierarchy. Now, what is this? How does it work? Now, what it does is it uses the links between concepts in order to understand their relation. And it does it by determining something called concept abstraction level. Now, what is it? Basically, it is basically the amount of concepts you need in order to define a concept. Now, what does it do? So, it can project how fundamental a concept is, meaning how much prior knowledge is needed in order to understand it. It can project how complex a concept is, meaning how likely it is to be automated. And it can map expected directions of technological advancement, and with it, skill demand changes, meaning what's going to change in our market. Now, as skills are concepts, it can be applied on skills as well, which is, well, quite important in our circumstances. So, why conceptual hierarchy? So there are a few advantages. First of all, it's a simple and effective method. It is a data-adapted method, but not so resource-demanding as most data-adapted methods. It is pretty moderate in resource consumption. It can project skill value for long periods of time, up to something like 30 years. It is clear and not a black box, which is very important if you speak to regulators, because of course they are liable and therefore they usually want to know what they are liable for. It creates a skill map by default. Just imagine for yourself a skill map of a computer game. Of course, this does not create a graphical representation, but that is definitely something you can do. And it is valuable also in the sub-planning of within a skill, meaning to plan sub-skills within a skill. Again, it's important to remember the skills are concepts, and as concepts, they are defined by sub-concepts. And okay, so let's speak a bit about abstraction. So what is concept abstraction? So abstraction is the ability to use concepts in order to define more complex concepts. Now let's begin with an example. So the concept dexterity describes coordination of small muscles, particularly fingers, with human eyes. Okay, so we have here 6 concepts. 6 concepts are used in order to define dexterity. However, if we're going to go and define dexterity, really, we're going to need to explore each and every single one of those concepts in the same way we explore dexterity. Now, I've done that for you, and the answer is about something like 900 concepts are needed in order to define dexterity alone. Now, of course, abstraction allows us to do that in one word, which means abstraction allows us to take a huge amount of information and consume and just use one word or one sentence in order to describe it. Now, why is that so important? Now, skills, after all, are concepts that are composed of a set of concepts. They are basically behaving the same. Now, the higher the abstraction level, the harder it is to automate the concept, because it is enough that you won't be able to automate one of the concepts, and then you cannot automate, of course, the highest concepts. If you cannot, for example, create coordination in something mechanical, then of course you cannot make something dexterous that is mechanical. And of course, the more concepts rely on another concepts, the more fundamental it is. Now, fundamental concepts are concepts that can be automated, but are still valuable because they are the stepping stone for so many concepts, they're still worthy of learning them. Okay, so what makes a skill valuable? Skill, of course, is a concept, but still they behave differently. So what makes them valuable? So 3 things can make a skill valuable. Regulation that protects its holder, such as an entry license like we have in medicine. Now, these things are hard to predict and of course are not covered by the method. And the main reason is that, well, what protects the skill actually is the regulation. This is the value of the skill, the regulation that is on it, not the skill itself. Now, another thing is high complexity that prevents automation. To that we call complex skills. And of course, fundamentability, meaning a skill that is the foundation of another skill that is needed. And those are foundational skills. Now, skills that are valuable are either complex or foundational. So, complex skills are hard to automate, and foundational skills are the key to learning other skills, and therefore they're valuable. So how do we detect each of them? So in order to detect complex skills, what we do is we analyze the abstraction level, meaning how many concepts are needed in order to define the concept. And the higher the abstraction level, the harder it is to automate the skill, and the higher the long-term value is. And the way we do it in our solution, is to do it by extracting concepts from lexical definitions. In fundamental skills, well, what we analyze is the reliance level, meaning how many concepts are needed and need our concept in order to be defined. Now, the more concepts rely on our concept, the more basic it is, and the more value there is in teaching it. Now, in our solution, we do that by mapping concept relevance in lexical dataset. Of course, that is all described in the rest of the papers. So, Another thing that this method can do is it can gap between skill to skill, meaning we can go take one skill and subtract from it another skill, and then get basically the difference, which will tell us what other sub-skills we have to complete in order to bridge from one skill to another. Now, what is interesting about that is, of course, that we can then easily understand what composes each skill, and we can easily bridge from skill to skill. And that pretty much revolutionizes anything that relates to learning program planning. It is pretty similar to a skill map in a computer game. Okay, so thank you very much for listening. And of course, all the resources are found in the appropriate places as requested in the challenge. And I hope you will find this project interesting. Thank you. Bye-bye.